Okay, I'm just going to do a quick video to show you how to go through topic test 2. First of all, you can go to the data files and calculator link. I'm in student view, so I have the same view as you. And in here you can download all of your data files that go with the eText, your SPSS data files. It's a zipped file, so you need to press it and extract the SPSS files. And then if you go to the topic test 2 link under data files, it'll take you to your topic test 2 data files. This link here has been created so that all of your data files are in the one spot. However, the traditional way to get your data files for your topic tests is just to navigate to topic test 2. So in the assessments link, scroll down, assessment 1, 10 topic tests, and in here you press on topic test 2. So here you will find your mytopictest.sav SPSS data file, and here you will find your trial.sav SPSS data file. So this trial topic test data file is to do the trial topic test, and this mytopictest.sav SPSS data file is to do the actual graded topic test. So you've got 10 of these. You would have done one in week 1 already. You have another 9 left, and for these you need your SPSS data file. For topic 10 I'm pretty sure you don't need it, for the rest you do. So let's open our trial.sav data file and we'll go through and have a look at the trial topic test. So it'll download. If you have SPSS installed already, then it will open. In fact, I can show you how to install, where to go to install SPSS if you haven't quite got that far. So we'll open the topic test. I'm just going to try and split the screen so we can be looking at both at the same time. Right, so you should complete this trial before completing topic test 2. The test can be saved and resumed later. It allows multiple tests because the trial topic test is not graded. So let's have a look. The very first question is, use the drop down menu to complete the following sentence. The first person in my data set either composts food scraps or does not compost food scraps. So here, ID 1 is the first person in my data set. I'm in data view. Here's my variable called compost. All participants in this compost variable are coded as 1 or 2, so it's a categorical variable. In your data file you'll have a label symbol. I have, you can press that symbol there and it will tell you the value labels. You've just got to find your compost variable. Do you compost food scraps? And the value labels are 1 for yes and 2 for no. Our person has a 1, so our person does compost food scraps, so we'll leave that as it is. Let's scroll down to the next question. The first person in my data set has a weekly income of how much money? It says 551 is already pre-filled because somebody's done this one. But let's have a look for my particular data set. All of you have different data sets. First person in my data set has a weekly income of something dollars. Give your answer as a whole number and do not include the dollar sign. So we need to find our variable that says income. Mine is $551, so I'll leave mine as it is. Yours won't be pre-filled. It's just I've got a demo user, so somebody else has logged in as a demo user and had a look. That's just because I'm a unit convener or an instructor. You guys won't have this, so don't worry, your questions won't be pre-filled. Question 3. The first person in my data set mainly travels by bus, train or car. Let's find our travel mode. There's our travel mode button. Now we can have a look here. We can go down to, what is your principal mode of transport? Car, train or bus? 1, 2 or 3. Ours is 3, so ours is bus. That's already been completed. Question 4. I want to know what proportion of teenagers in the mythical country of Catatonia have an iPad. I randomly select 45 students who attend the prestigious Cats Ladies College and record whether or not they have an iPad. Note, if the sample is properly selected, 45 is a reasonable sized sample for this study. What is the population from which the sample was drawn? So I want to know what proportion of teenagers in the mythical country of Catatonia have an iPad. I randomly select 45 students who attend the prestigious Ladies Cats College and record. So the population from which the sample was drawn was all students who attend Cats Ladies College. because we randomly selected 45 students from everybody who attends Cats Ladies College. So even though the population of interest is all teenagers in Catatonia, the population from which the sample was drawn was only Cats Ladies College. So that's the population from which the sample was drawn. If we want to draw a conclusion about all Catatonian teenagers, the sample is probably biased because students who attend Cats Ladies College may not be representative of all teenagers, particularly as they're obviously only female. So we haven't got any males in our sample. So the population from which we drew our sample is not going to be representative of all Catatonian teenagers, which is what the research question, which is with whom the research question was concerned. Of the 45 students who answered the question, 43 have an iPad. What proportion of students in the sample have an iPad? So we need to obviously open our calculator, and we go 43 divided by 45 equals 0.955. So we're going to do it to 2 decimal places. So we will write 0.96. So 43 out of 45 people is 0.46. Just making sure it was 45. Okay, so from this sample statistic, what can we conclude about the proportion of Catatonian teachers who have an iPad? Catatonian teenagers who have an iPad. We cannot say anything about the proportion of Catatonian teenagers who have an iPad. The proportion of Catatonian teenagers who have an iPad is the proportion I calculated. A high proportion of Catatonian teenagers have an iPad. So we cannot say anything about Catatonian teenagers generally because the sample we drew was not representative of Catatonian teenagers generally. We can only say something about Catatonian teenagers who attend Cats Ladies College. Normal distribution. Native-born Catatonians tend to be very tall. Suppose that the heights of Catatonian men are approximately normally distributed, which means we know a lot about the sample, with a mean of 205 centimetres and a standard deviation of 15 centimetres. Complete the following sentence, giving figures from lowest to highest to the nearest whole number, for example 96. 95% of Catatonian men would have heights between what and what. So we know that 95% of cases within a normal distribution are within 2 standard deviations of the mean. So 15 centimetres is the standard deviation, so we times that by 2. We need to subtract, that gives us 30 centimetres. We need to subtract 30 centimetres from 205 to get the lower end of the 95% confidence interval. That gives us 175 centimetres. And then we need to plus 30. That gives us 235 centimetres. So we know that 95% of Catatonian men would have heights between 175 centimetres and 235 centimetres. So question 9. While travelling in Catatonia, I met a man who was 170 centimetres tall. How many standard deviations from the mean is this man's height? Give your answer correct to 2 decimal places and include the negative sign if the height is below the mean. So basically what we need to do is we take x, 170, minus the mean, which is 205, and divide by the standard deviation is 15, because that gives us the z-score. So we need to go x is 170 minus 205 equals divided by 15, the standard deviation, gives us negative 2.3. Now we know that we knew that z-score was going to be more than 2 standard deviations from the mean because it's this figure 170 centimetres is not within 95% of scores. So this person is extremely short for a Catatonian. It's a very unusual score because it's a z-score that's more than 2. More than negative 2 is an unusual z-score, and more than positive 2 is an unusual z-score. So this man's height is unusually low for a native Catatonian. From this we can conclude that the man is probably not a native of Catatonia. The man is probably a native of Catatonia. We can't conclude anything. So we'll conclude this is the whole basis of inferential statistics, that if a particular case is more than 2 standard deviations from the mean, we say that person would be very unusual for that population, And so we conclude it's obviously not going to be true 100% of the time, but in 5% of the time we'll be wrong, because 5% of cases in any normally distributed sample will be extremely unusual. There will be more than 2 standard deviations from the mean. But nonetheless, in statistics, if a case is more than 2 standard deviations from the mean, it is typical to conclude that that case is unlikely to come from that particular population. So we're going to say this man is probably not a native of Catatonia. Okay? Now let's just go back through, see if I made a mistake with any of my calculations, because if I did, it's highly likely that you guys might have made those mistakes too. So let's just have a little look if there might be a decimal place error or something like that. Great. It's not going to load for me. Awesome.